Good day to Dr. Norfa. This is the video presentation for Probability and Statistical Data Analysis Project 2. And in this project, we aim to look into the relationship between the different risk factors in human health. And this is from section 02. My group mate is Afik and Venice, and me, I'm Yuli. So should start with the presentation. So this presentation covers 5 parts. The first one is introduction, followed by methodology, data set, data analysis, where we will conduct 4 hypothesis tests, and the final one is the conclusion. So in this introduction, based on a statistic conducted in 2022, around 95,000 death cases were reported in 2022 alone, and 12,000 or more than 12,000 cases are related to heart disease and also other health condition issues such as lung cancer, liver diseases, or this pneumonia here. And while heart diseases is the top killer in 2022, we also want to look into other factors such as high cholesterol levels, high blood pressure, aging, and unhealthy lifestyles that also significantly contributed to it. And hence, among all the methodology that we apply in this project, first is sample statistic, the main thing, where we manipulate the raw data obtained and then aim to make references of the population selected. And also others like the descriptive statistics is when we categorize and we tabulate the raw data, and inferential statistics is when we draw conclusion or we make hypothesis tests on this data. And also level of measurement, it involves, for example, data of different types. We have nominal, ordinal, interval, and ratio. And next data set. So the data set selected in this project is a heart disease health indicators data set. Although it is conducted by an organization, the sample is Americans, but I guess is not I guess, but it is applicable to the subject of study. So among all the set of data available in that report, there are 22 of them, but we only use 7. The 7, and first we have the cholesterol check. It is a nominal data, and then high cholesterol is also a nominal data, with 1 indicating yes and 0 indicating no, and age is ratio. Heart disease is nominal, BMI is ratio, which can be calculated using height and mean. And next is smoking status. This one is also nominal, with general health is ordinal. It is a rating from 1 to 5, with 1 being the most unhealthy and 5 being the most healthy. And next, we look at the first hypothesis, the first data analysis, which is the 2 sample hypothesis testing. In this one, we have 2 variables. The first is the mean of cholesterol check. Second is the mean of high cholesterol level. Our hypothesis statement is that the mean of cholesterol check, or mean 1, is equal to mean 2, while the alternative statement being that the mean cholesterol check is smaller than the mean of high cholesterol level. And so when we conduct the test statistic, we assume that these two have unequal variance. So this is the formula to calculate the test statistic, or we can just use our programming to obtain this value here. So the t-test value is negative 512 point something. And next we have this degree of freedom. So by plugging in the formula, as for the sample of standard deviation of sample, and then we obtain the degree of freedom, which is this value here. And then from the value here and also the significance level, we can obtain the critical value. So therefore, we can draw the conclusion here. Since the t-test, since the test statistic is small, is five, if it's negative 512 point something, so it is much smaller than the critical value. Hence, we reject the null hypothesis, and there's sufficient evidence at 0.05 significance level to conclude that the mean of cholesterol test is lower than the mean of high cholesterol level. Moving on to the next data analysis, which is correlation test. In this one, we also have two variables, with x being age, y is the frequency of heart disease. The hypothesis statement for null hypothesis is there's no linear correlation between age and the frequency of heart disease occurrence, while the alternative statement is that there is a linear correlation exists between age and the frequency of heart disease. And since both age and frequency of heart disease are of ratio data type, so we can apply the Pearson's correlation coefficient, and this is the formula here. And by using R programming, we can obtain the value of R, which is equal to 0.9350. So while I move on to test statistic, we can show perhaps the graph we have here. So based on this graph, we can observe that there's actually a very strong positive linear relationship between age and the frequency of heart disease occurrence, and also from the value of R, which is 0.9 something, which is very close to 1, also is a more accurate indicators that with an increase in age, there's actually a linear increase in the frequency of heart disease occurrence. So we go back to this test statistic. So this is the formula, and then we plug in a value of R and N, and we'll get the value of T. So for the critical value, since it is a two-tailed test and with alpha, the significance level, and then we obtain a critical value equal to plus minus 1.96. So the conclusion of this test is that since the test statistic is greater than the critical value, hence we reject the null hypothesis. There is sufficient evidence at 0.05 significance level to conclude that there exists a linear relationship between age and the frequency of heart disease occurrence. And oops. Next, the third one is regression analysis. For this one, the independent variable is the BMI index, while the dependent variable is the frequency of heart disease occurrence, just like the previous correlation test. So for hypothesis statement, for the null hypothesis, there's no linear relationship between BMI index and the frequency of heart disease, while the alternative statement being that there is linear relationship exists between BMI index and the frequency of heart disease. The estimated regression model for this one, there's the formula here, and then we can plug in the value of y and x. And no, we can plug in the value of x, and then we'll get that of y. So explain and unexplained variation. This one we'll get the sum of square regression, sum of square error, and then from this two we can calculate the total sum of square, and then we can also use this tool to obtain the coefficient of determination R squared. And then the standard error of estimate, we plug in the value and we got this one. So next is the standard deviation of regression slope, and the test statistic here is negative 0.077, while the critical value being plus minus 1.96 since it's a two-tailed test. So the conclusion is that since the test statistic is greater than the critical value, it falls in the rejection region. So we, oops, wait, test statistic is greater. Hold on. Okay, yeah. Now, the test statistic is negative 0.077, which is greater than the lower tail of the critical value. Hence, it is still inside the acceptance region or the acceptance zone, so we fail to reject the null hypothesis. There is insufficient evidence at 0.05 significance level to support the claim that BMI index affects the frequency of heart disease occurrence. Next, the last data analysis is the chi-square test of independence. So this is the tabulated data. So we have smoking, 0 indicates non-smoker, 1 is smoker, while the health condition is a rating from 1 to 5. This is the most unhealthy, 5 is the most healthy. And then this table is important for us to calculate the expected value. So we start with the hypothesis statement first. For the null hypothesis, we have the general health condition is independent of smoking status, meaning there's no relationship between these two. While the alternative statement is the general health condition is not independent of smoking status. And then, as I said, from the table before this, we can calculate the expected value by, for example, the row 1 and column 1, this cell. The expected value of this should be the total of this row times the total of this column divided by the total sample size. And then we repeat this one for every cell inside here. And when we have the observed and expected value, we can plug this value in and obtain the chi-square value of each of these cells. We sum it up, so we will get the test statistic, which is equal to 6,777.15. While the critical value for the degree of freedom, this one is obtained by the number of row minus 1 times the number of column minus 1, so we get 4 here. So the critical value equal to 7.81. Hence, we can draw the conclusion that since the chi-square value is greater than the critical value, we reject the null hypothesis. And there is sufficient evidence at 0.05 significance level to conclude that the general health condition is not independent of smoking, meaning that there is a relationship between these two variables. And hence, here comes the conclusion of this project. We will sum up each of the hypotheses or each of the analysis conducted before this. So for the first one, we can conclude that there's fewer individuals undergo cholesterol check despite a high prevalence of high cholesterol levels among citizens, showing that there's a neglect in cholesterol monitoring. There's actually more people with cholesterol related problem, but they did not go to cholesterol check. And then the second one is there is a strong positive relationship between age and the frequency of heart disease, highlighting the increased risk of heart disease with aging. This one signal that maybe elderly should be more aware of their risk of heart disease and take some preventive steps. While the third analysis, we can conclude that BMI does not significantly affect heart disease frequency, suggesting that other risk factors may be more critical. While this one does not imply that people with a, for example, with an overweight or obese BMI, they are not prone to heart disease or they are not prone to heart disease or related health condition issues. But this one is aimed to convey the message that while you might have a normal BMI, but you're equally prone to getting a heart disease or any other health condition issues. The last one is that there's a significant impact of smoking on overall health, reinforcing the need for a public health initiative to reduce smoking rates. And the overall conclusion of this is that this project showcased the importance of statistical analysis and programming in identifying and interpreting health risk factors, aiding healthcare professionals in better understanding. And that's all for the presentation for project 2 of PSDA. And thank you for watching.